Thank you very much. Yes, it's an excellent segue to my talk, the question itself, and of course, the presentation that my colleague Jürgen just gave. So I very much appreciate the opportunity to address you. The stratigraphic record of the Anthropocene is my topic, so it will attempt to explain what the question that was rejected by the International Commission on Stratigraphy, what it was and how it really fails to appreciate the complexity of the proposal by Paul Crutzen, a member of this academy, that we are no longer living in the Holocene, and that to illustrate that, it is important that we recognize that we're in a new geological epoch, one that should be named for the geological agent that produced the change, Anthropos. So the term Anthropocene was suggested as a good one on the fly at a meeting in Mexico in the year 2000. Now, unfortunately, the geologists ignored that concept, it being outside of the realm of their rock hammer, cliff of rock kind of way of thinking, for 8 years. And in those 8 years, people in the humanities and social sciences really took up that term. It resonated with them. It had become apparent to many people that the world we were living in is no longer a Holocene world. Now, unfortunately, it's not a matter of a fiat. You know, we're in the Anthropocene epoch is not good enough. Geologists have a very traditional, very legalistic way of putting a new line on this time scale that breaks down 4.6 billion years of Earth history with boundaries between units recognizing major changes in the Earth system. So the one that most people are familiar with, the extinction of the dinosaurs and many other taxa 65 million years or so ago due to the meteoroid impact on the planet. That is the boundary between the Mesozoic and Cenozoic era. So the idea is that those different colors that you see represent distinctly different operational modes of planet Earth. And the suggestion then on the fly by Paul Crutzen was there should be an Anthropocene epoch, that we already in 2000 were living in such an epoch. And his intuition at the time was that this was triggered by the Industrial Revolution. And so he then assumed that a starting point for the Anthropocene, or the base of the Anthropocene, would be sort of late 18th century. Now, the thing is, when you have a line on that time scale, what is required is strata, of geologic strata of some sort, that show the change to a new operational mode of the planet from the old one, so that you can put your finger on that rock or ice core or speleothem, stalactite. Those are examples of the kinds of series that have been used to demark epochs and the boundaries between them. So the question was, for several years, what boundaries should we look for, and what kinds of Earth material should we look for, and where should we look for them? So they looked at the literature for about a decade and recognized that the big change in all reported literature was mid-20th century. It wasn't late 18th century, it was mid-20th century. And as Jürgen pointed out earlier, that is the Great Acceleration. So that nick point was the focus of our efforts. And there were 12 sites examined, and one of them was the site that I'd been studying, Crawford Lake in Canada, so that's the one I'll focus on in this presentation. So the proposal placed before the International Commission on Stratigraphy's subcommission on the Quaternary was a 161-page report with lots of data from 12 sites, and it proposed the erection of an Anthropocene epoch and a Crawfordian age. The fact that they did not address the issue of the Crawfordian age suggests that they didn't read the proposal very carefully to start with, because in answer to the question that was posed earlier, we really did not get any formal response to the proposal. Everything we've heard of their objection to it has been through the media, has been third hand, really. So it's, yeah, frustrating. So, not going to dwell on this because Jürgen did a good job mentioning it, but the Earth system trends really parallel the socioeconomic trends in the mid-20th century, post-war boom, and it is a subject that has been termed the Great Acceleration by our colleagues in the social sciences and humanities, and the Earth system scientists recognize the significance of those changes, how they affected the Earth system. So my colleague Martin Head, who was a member of the Anthropocene Working Group before I was invited to join, well, they were looking for the kinds of geologic environments to look in detail at the 20th century and see if there is, in fact, truth to Crutzen's off-the-cuff, we're no longer living in the Holocene statement. Is there stratigraphic reality? That's what matters to earth scientists, to stratigraphers. Can we see it in the geologic record? As you can sort of see in this diagram, there are annual layers, what we call varves, that accumulate in Crawford Lake. And so we can very precisely identify each layer and sample year by year to identify what's happened. And since 1970, it was known that there were two distinct impacts on the lake by human activity. So anthropogenic impacts, initially by Indigenous people who subsisted primarily on the Three Sisters agriculture, and the colonial impact in the 19th century, particularly the 30 years of operation of a sawmill at the lake. But no one had really looked in detail at the 20th century, because why would you look in detail at the 20th century when all you can, it's much easier to look at historical records. You know, why would you put all that effort into it? So I said, well, I would do it, so I did, and with many, many colleagues. And Crawford Lake is close to the US border. It is just north of Lake Ontario. It's between Toronto and Hamilton. It's actually downwind of Hamilton, Hamilton being a mid-sized, highly industrial city. And it's that impact of industry on lakes in general that is really important, because as you'll see in a few minutes, lakes are really good places to accumulate high-resolution records. So the lake itself is within a protected conservation area, and it's been protected since 1969. And there are longhouses reconstructed on the site on the very footprint, archaeological footprint of where they were in the 15th century. And the Indigenous name in Wendake that was chosen very recently for this site, because it didn't have a name until recently, really focuses on the importance to the entire world, because the name means where we have a story to tell. And the image on the right is, of course, a close-up of these layered sediments, with the white being every summer. So like tree rings, we can identify each and every year. And this is an image of the varves, as one of our Indigenous elders who's been working with us portrayed it and linked it with her ancestral traditions. So I think that also ties in with what Jürgen was saying. There are many ways of looking at the story, and many people own it. It's not just geologists. So that's me at a recent TED Talk, and on the behind me you can see where the locations of the various sites that the Anthropocene Working Group examined. And these are little summaries of the 12 sites, and the colors show you the kinds of records, so that the sort of bluey green are lakes, and that line that goes across is 1952, and you can see that those blobs that represent 4 key markers of the Anthropocene, 2 of which are markers of the great acceleration of that industry and growth in the human population and so on, and 2 are nuclear age, because it is the fallout of the products of thermonuclear weapons that are the synchronous, geosynchronous, all around the world, that demark the moment that we've defined the Anthropocene. So just a few pretty pictures of field work, because we don't have time to really belabor this, and yes. And unfortunately, global warming means that even in Canada, we don't always have safe ice in the winter. So the last time we needed to go out, we couldn't core easily from the ice. So this is an aerial view, a drone view of the raft that we use to collect our most recent set of cores. Those that clinched the selection of Crawford Lake as the golden spike, as that line on the time scale to be proposed to the International Commission on Stratigraphy. So lots of work goes into getting the cores, getting the individual layers sampled. Many analysts were involved in analyzing the data. I'm not going to talk about all the data because there isn't time, but that green line again is 1952, and many things change at that point. And biological, physical, chemical changes, geologic changes, all of these are recorded in the geologic record. But the one that just zoomed in, that looks like a little asteroid, is a spheroidal carbonaceous particle, or an SCP. These are little tiny fly ash particles, and that's the one I'm going to focus on in the next slide. There's a global record at the top center of SCPs. These are not just our Anthropocene Working Group sites, and there is a clear uptick with the great acceleration, and then there's a decline later, and that has to do with technological innovations to capture particulates, to lessen the impact on air quality of what we continue to do is combust fossil fuels. So these are produced, fly ash is produced by high temperature combustion of fossil fuels in places like Hamilton, the steel mills that you see in this image. And 6 of the 12 sites, I've placed images or graphs of the SCP, and again, the green line. You can see that there is, lots of coherence across around the world. From the left is California, to the right is Japan, different parts of the world recognizing or capturing the same signal. But if you just look at that bottom graph again, and the 6 graphs, there is a bit of diachronaity, and you can see that Asia on the right is later than North America and Europe on the left, and that's because industrialization came a little bit later. But what is not diachronous, what is synchronous, is that fallout from nuclear explosions, atmospheric tests of thermonuclear weapons. And again, these are the same sites, and you can see the synchronicity across the sites, and 1952. And this is a close-up of the record of plutonium in Crawford Lake. So it was agreed back in 2019 that plutonium-239, which is in itself an anthropogenic isotope, it virtually is non-existent without humans detonating thermonuclear weapons, atomic weapons. And the pattern that we see in Crawford Lake exactly mimics the pattern that you see in nuclear fallout. That pattern is at the bottom right. So it shows you the number of nuclear tests, the black histograms, the blue, I'm talking about the bottom diagram, the blue being the plutonium fallout, and the top 2 diagrams, of course, are the data from Crawford Lake, We have data from 3 different cores to show how consistent our data are. And in addition to having very same patterns, including catching that moratorium, that short moratorium in between 58 and 1960, we have an interesting trough in the ratio of plutonium-240, 239 that no one had ever noticed before, that is really characteristic of that boundary between the what we propose, the Holocene and the Anthropocene. And here are the plutonium-239 plus 240 data pictured or pasted against a close-up of our sediment core. So you can see the individual layers capped by white every summer. And the reason for the exact precise moment in time that we have suggested marks the beginning of the Anthropocene is the detonation of Ivy Mike, the very first H-bomb. We do have a record of atomic bombs, including Trinity, the very first test in the southwestern US desert, but across the world, the amount of plutonium that falls out from H-bombs is so much greater that really that's the one that's globally synchronous, even though at Crawford Lake we do capture the earlier ones. So the top left diagram shows you the record of cesium-137, which is another product of nuclear fallout, the black curve. In Crawford Lake, the red is the global fallout, and the blue is the amount of phosphorus applied as fertilizer to fields, so that you can see how closely that nuclear fallout shows the beginning of the Anthropocene and ties in with that great acceleration. So we really felt strongly that we had good evidence, not only from Crawford Lake, but from all 12 sites that we studied and other sites that had been published before for this Anthropocene. And it captured the imagination of the world in a way that we didn't expect. And there was an editorial in the Washington Post in 2023, the year of Barbie and Oppenheimer, that suggested that Barbie and Oppenheimer tell the same terrifying story, and they cited the record at Crawford Lake in linking the nuclear era with the Great Acceleration. And of course, we submitted that thick and meaty, data-rich proposal for an Anthropocene epoch and a Crawfordian age on October 31st, 2023. It was rejected shortly thereafter with very, very little discussion at committee. No questions were fed back to us, and there was very little discussion within the committee. They just wanted to vote. They had already made up their minds, and it made news around the world. My favorite article was, "The Anthropocene is dead, long live the Anthropocene." So that's what I live by. So why is it important? The Great Acceleration. We've seen these graphs before. They've had an impact. They continue to have an impact, regardless of whether we meet the Paris Agreement goals, which is doubtful. The residence time of greenhouse gases is far too long to turn back time. We live in an Anthropocene world, and as Jürgen said, mitigation can have some effects at this point, but we really have to learn to live in a world that is operating in a no analog state, in one that humans have not experienced before. And that is the critical issue for humanity, is that within decades, we will be experiencing conditions that humans have not lived through. And that needs to be dealt with. And for me, the rejection by stratigraphers of a line on the timescale, the insistence that we're still living in the Holocene, that Paul Crutzen was wrong, that we haven't altered the planet to the point that we need to recognize it by a line on the timescale, by naming a new epoch, is dangerous because it ignores the importance of earth sciences to dealing with this issue. And I'll show you one slide that is really scary And that is a slide of sea level in the last interglacial, Eemian, or Sangamonian as we say in North America, 128,000 years ago. And sea level through the Holocene, and then that little blue dot shows and it shows you the relationship between sea level and mean global temperature. And the little blue dot is the temperature of the last 2 years. And you can see that we are basically at the point where the last interglacial reached, and sea level was 6 to 8 meters higher globally. And if you picture the number of people and the amount of infrastructure within 6 to 8 meters of sea level, it is terrifying. So the question bolded at the end of Hannah Fry's little summary there, can these scientists, the Anthropocene Working Group, convince their colleagues and the world? And my plea is that, irrespective of a line on the timescale, that the world recognizes that we cannot go back to Holocene conditions. The world doesn't play by the same rules, and we have to learn very, very, very quickly how to deal with that.